Okay, hello everyone. Welcome back to the lecture series on expectation value of a physical observable A. In our last class, we have been discussed in detail how we are going to represent the expectation value of a physical observable A. In general, it has been represented as this format. Why and how we have been discussed with the help of two examples. One, one is your average age or mean age of a group of students, and another one, the center of mass of a discrete distribution of masses of a rod. Okay, and this distribution of masses is connected to the quantum dynamics. Mass is substituted as your probability density at each and every point on this rod, and finally we found the expectation value of a physical observable quantity will be represented in this way. This is the one dimensional representation. Two dimensional means we have to consider double integration dx dy, and for three dimensional it will be triple integration dx dy dz or dqr we can write. Okay, now today class we are going to solve some numericals based upon this expectation value of the physical observable quantity. Okay, here is the numerical. First numerical, here you can see we consider one dimensional box in which an quantum particle moving from x equal 0 to L. Here you can see the quantum particle moving from x equal 0 to x equal L. The total length of this rod is L. The normalized wave function of this particle is given this one. This is the normalized wave function. That means particle is in free motion from 0 x equal 0 to x equal to L, and particle could not move beyond x equal to L and x equal to 0. It is confined in this region. Okay, and it is moving this way. So this also can be represented like this one. At x equal 0, a infinite potential or infinite wall, we can say that it could not be penetrated in this way. At x equal L also it could not be penetrated along uh, right side. Okay, so it can be represented mathematically as in between 0 to L the wave function or the particle exists, and it is represented by 2 by L root over sine n pi x by L, and this is the normalized wave function also. We know this one for one dimensional box, and particle does not exist except this length. First we have to calculate for this quantum dynamics expectation value of the position or the most probable position of the particle, which is represented by this one x cap in between angle bracket. Okay, so try to solve it. In general, expectation value of the position is will be written as what for this quantum dynamics. For this quantum dynamics will be written in this format. Here I am going to write here x cap expectation value will be written as minus infinity to plus infinity psi star x cap psi dx whole divided by minus infinity to plus infinity psi star psi dx. We know this denominator value equal to 1 for a normalized wave function. In the question it has been given this wave function is a normalized, so the denominator will be 1. Okay, now we found this value only. X cap expectation value will be minus infinity to plus infinity psi star x psi dx. Okay, it can be written as minus infinity to 0 psi star x psi dx plus 0 to L psi star x psi dx, then plus L to infinite psi star x psi dx. Okay, in the question it has been given that wave function exists in between 0 to L, elsewhere it is 0. So minus infinity to 0, this value will be 0 because psi is 0, psi star also 0, so this value will be 0. So above L, that means from L to infinite, this value also will be 0. So we can found this one. Okay, so directly I have been written this one. For this problem or for this situation, expectation value of the position of this quantum dynamics is equal to 0 to L psi star x cap psi dx, and x cap value is nothing but x psi dx. I just omitted these steps I just omitted. Okay. So here I written as this wave function is normalized, psi star psi dx equal to 1 from 0 to L. Okay. Now uh, we have to just solve with by considering this wave function, this value 2 by L sine n pi x by L. Now we are going to substitute psi star value psi. Here you can see the given wave function is not the imaginary. We do not have any imaginary term or terms in this wave function. So its star value or its complex conjugate will be also this much. Okay. So now we are going to substitute here psi star and psi. What will the value here? That implies expectation value of the position or x will be 0 to L 2 by L root over sine n pi x by L. X as such it has been written, and same value 2 by L root over sine n pi x by L dx, right? That implies here 2 by L root over 2 by L root over, so it will be 2 by L taken outside of this integration, 0 to L x, here sine n pi x by L sine n pi x by L, so it will be sine square n pi x by L dx. 2 by L 0 to L sine square n pi x by L can be written as 1 minus cos 2 n pi x by L by 2, because we know that sine square x can be written as 1 minus cos 2x by 2, right? So only for that sine square n pi x by L can be written this one, right? Now here x, here 2, here 1 2 got cancelled, so it will be 1 by L, and one term we can get x dx and another term will be x, this x will be multiplied with this one, so x cos 2 n pi x by L dx. Got it? Now 1 by L, just integrate this one, it will be x square by 2 0 to L limiting value, and integration of this one we have to apply the by parts. Here you can see if I'm going to consider by parts LAT ILAT, so inverse, logarithmic, arithmetic, and then trigonometric. So arithmetic will be the first function, x will be the first function, then integration of the second function, that is your cos, uh, then minus here 0 to L integration limit, 0 to L integration limit, first function derivative, then second function integration cos. Okay, so here dx, here whole dx, right? So the first term will be how much? X cos x integration is your sin x, or cos ax, if we have integration will be sin ax by a. So here cos 2n pi x by L, so its value will be x sin 2n pi x by L by 2n pi by L, and the limit will be 0 to L, right? Minus here derivative of x, this value will be 1, then cos ax integration will be sin x by a, sin ax by a, then again integration it will be minus cos sin x integration minus cos ax by a, already is there, so it will be a square, and the limit will be what? 0 to L, already minus is there, and this minus will be plus, so I directly written plus cos 2n pi x by L by 2n, this is a, here a is nothing but 2n pi L square, 0 to L the limits, 0 is the lower limit, L is the upper limit. Now just substitute limits. 1 by L, this will be, if I put L over here, L square by 2, 0 means 0, no need to write, so L square by 2 we found, minus here you can see, if I put L over here, this L got cancelled, we can found sin 2n pi, sin 2n pi value is 0 always. Okay, then put 0, if I put 0 over here, then this term also 0, and sin 0 itself 0, so this value always be 0, I written. Okay, now put L over here, this will be cos 2n pi. Okay, cos 2n pi value will be always 1, because cos n equal to 0 1 2 we can put, no, so for n equal to 0 it will be 1, cos n equal to 1 it will be 2 pi, cos 2 pi 1, then if we are going to put n equal to 3, then it will be 6 pi, also it will be 1, so cos 2n pi always 1, right? Then if I'm going to put 0 over here, lower limit also 1, cos 0 1. So here 1 minus 1, so this term also cancelled out. Likewise, these two terms will be 0 0, and here L and L got cancelled. Finally we can found expectation value of this quantum dynamics or one dimensional box, that particle moving along uh, one dimensionally or along x-axis as shown in the figure in the length of L 0 to L. And here we found expectation value equal to L by 2. That means most of the time or mostly the particle found at L by 2 here. This is the most probable position to finding the particle, where at x L by 2, exactly at the middle of this length. And this position is called the most probable finding position or most probability position to finding the particle. This is the position where the particle mostly found, or the so-called expectation value, mean value, what we found L by 2. This is the answer. Okay, now we are going to go for our next question. By considering the uh, same quantum dynamics, we have to find out the momentum expectation value. Okay, so let's go for the solution. That expectation value in general, what we have to write, this one divided by 0 to L psi star psi dx, this value will be 1. No need to write. Okay, 0 to L psi star, and px cap. In our first video, previous video, we discussed that px cap is nothing but operator, this operator, momentum operator value is your iota. This is the imaginary. Iota means root over of minus 1 minus iota h cross. Here reduced, this h cross means h by 2 pi, reduced Planck constant, h cross by into del by del x of psi dx. Now that implies expectation value of momentum is equal to 0 to L, lower and upper limit. We have to just substitute psi star value is this one, and psi value is this much, and this is the operator value of the momentum along x-axis. Okay, okay. Here minus iota h cross taken outside of the integration. Here 2 by L root over 2 by L root over, that will be 2 by L taken outside of the integration, 0 to L. This will be sine n pi x by L, and this del by del x will be operate over the sine n pi x by L dx. So this value will be n pi by L cos n pi x by L dx, and others as such it has been written. That implies expectation value of the momentum will be I h cross. Here you can see n pi by L, here 2 n pi by L taken outside of this integration, it will be 2 n pi by L square, 0 to L integration limit, sine n pi x by L cos n pi x by L dx, right? That implies expectation value of the momentum will be iota h cross. Here this 2 into sine n pi x by L into cos n pi x by L can be written as sine 2n pi x by L. Why and how? Because we know that 2 sine A into cos B is nothing but sine A plus B plus sine A minus B. Here you can consider 2 into sine. Consider this one is your A and this one is your B. Here A and B both are equal. So sine, the first term will be sine A plus B. Sine A plus means B means 2n pi x by L. Then cos A minus B. Cos A minus B means cos 0. We can get cos 0. Cos 0 value is your 1. So into 1, I not written that one dx. Right? Okay. Now we have to just integrate. Sine ax integration is your what? Sine ax integration is your what? Minus cos ax by a. So here a is nothing but this one, this value 2n pi by L. So integration of this one will be how much? Here iota h cross n pi by L square written as such. This will be minus, this will be minus, mistakenly not written, this will be minus cos 2n pi x by L by 2n pi L, 2n pi by L, limit will be 0 to L. Okay, here you can see minus minus, it will be plus, but here if I put upper limit L, this will be cos to n pi, value is your 1. Then minus lower limit, if I put here x cos 0, cos 0 is also 1. So finally we can found 0. Okay, so here we found the expectation value of momentum for this quantum dynamics or one dimensional box problem. How much we found this one? Okay, the momentum for this dynamics is 0. What is the physical meaning of this 0 answer? Here you can see momentum. We know uh, momentum is nothing but a vector quantity mv. Okay, so this particle which is confined in a one dimensional potential box only moving along x-axis, moving forward and backward. So in an average we can say for the forward it is plus, so suppose for the backward it is minus. Vectorially if we are going to add at particular instant, so it will be 0, mv for the forward plus m minus v for the backward. Okay, so hence it will be 0. So momentum for expectation value of the momentum of this dynamics, what we found, 0. But this integration value will be minus. Okay, I forgot, first I have to correct it. Wait. Okay, I corrected this one. Okay, so expectation value of the momentum of this dynamics we found 0. Now we are going to go for expectation value of total energy is represented by like E cap in between angle bracket or H cap. H cap is nothing but Hamiltonian. Okay, that means kinetic energy plus potential energy, so called total energy. So let's get the solution of this question. So in general it can be written as psi star E cap psi dx. Okay, or you can write instead of E cap H cap. It will better you just practice H cap instead of E cap. Okay, psi E cap psi dx. Here E cap is nothing but T cap plus V cap. T is nothing but your kinetic energy operator and potential. This is the potential energy operator. So here the particle is exist inside this length, in between this length 0 to L. In between this length it is freely moving. There is no potential or there is no force. The force only exerted at x equal to 0 and x equal to L, where particle does not exist itself. So in between x equal to 0 and x equal to L, or in this length, particle is in free motion. Free motion means there is no potential, so this value will be 0. So for this dynamics, the total energy or the Hamiltonian is nothing but your kinetic energy only. So kinetic energy operator, what is that? P square by 2m. P square by 2m. P is what? Minus IH cross del by del x. If I am going to consider square of this one, it will be how much? Minus h cross square del square by del x square. And already 2m is there, 2m. So Tx cap is nothing but minus h cross square by 2m del square by del x square psi dx. Got it? So for this dynamics, total energy operator value is this much. First it will operate over psi, then it will be multiplied. Go for the answer. Substitute psi star value over here and psi value. Both are same because it is both are real. So both are same. 2 by L root over and 2 by L root over h cot square by 2m taken outside of the integration. It will be 2 by L root over. So it will be 2 by L and integration limit x equal 0 to L sine n pi x by L, and this is the double derivative of this one, sine n pi x by L, right? So if I am going to do the double derivative of this one, first derivative is your cos, second derivative is your minus sine, and this factor will be multiplied 2 times. So it will be n pi L square and sine का derivative cos होगा, cos का again minus sine होगा, so minus sine n pi x by L dx, right? This factor is a constant taken outside of this integration, and here this minus and this is another minus is the plus h cross square by 2m 2 by L n pi L whole square and 0 to L integration limits sine n pi x by L into sine n pi x by L dx. Here 2 into this much, 2 into this much is written as this much. Why? Because we know that 2 sine A into sine B is your cos A minus B minus cos A plus B. Here A and B, here you can see A and B both are equal. So this value will be how much? Cos 0. Cos 0 is nothing but 1. So first term we got the 1 minus cos A plus B. Cos A plus B means it will be 2 into n pi x by L. So cos 2n pi x by L dx. Got it? Very good. Next, that implies expectation value of the total energy will be equal to h cross square by 2m 1 by L n pi L square, and here integration of this one only 1 will be x, and integration of this one it will be sine 2n pi x by L by this much. This is a constant factor by this one 0 to L. Just put the upper limit and lower limit. Just put the upper limit first. So it will be L, and if I will put upper limit over here, L got cancelled, sine 2n pi 0. Okay, so we can found L minus 0. If I will put lower limit here, this 0, and here also sine 0 0. Okay, so we can found L minus 0 by substituting upper limit and lower limit. Here you can see this is your L, this is your L square, LQ, and this is L got cancelled. We found n square pi square h cross square by 2m L square. May you have been remember that the eigenfunction of this one-dimensional potential box, potential box is your n square pi square, whatever we found 2m L square. Here we got the same. If I am going to consider the ground state value, and this is the answer. Okay, this is the expectation value of total energy or eigenvalues of this dynamics. So by substituting n value, n equal to 0, 1, 2, 3, 4, so on, if I will substitute 1, we can find the ground state value here. If I will substitute 1, n equal to 1, pi square h square square 2m L square, this is the ground state energy, this is the first excited, this is the second excited state energy value, which is discrete. For n equal to 1, this value, for n equal to 2, so here the gap between two energy levels gradually increases for one-dimensional box. Particle moving to and fro along x-axis or along a particular length. So here we found this is the expectation value of the total energy of this dynamics. Okay. So here we have to stop our discussion for this class. Next class we are going to discuss a verification of Heisenberg uncertainty principle, that we know del x cap into del px cap is greater than or equal to h cross by 2, where del x cap and del px cap are represent the uh, uncertainty position and momentum of a particle. Okay, so thank you so much for watching this video, and I'll give all the notes of this lecture series, and the link I'll give in the description. You can download, link available in the description. Okay, description for all the notes of this lecture series. You can download and prepare for your exam. Thank you so much for watching this video. Thank you.